Hello ATM, this is going to be a video on the 4-8 class portion. To be honest, this in my opinion should have been the group portion because it's just a big review on algebraic operations. As you can see for question number 1, we're taking this first polynomial and we're adding it to the second polynomial. So I'm going to go through some of the tips to help you remember what to do and what not to do. But ideally what I'd like you guys to do is pause the video and try the problem on your own and then go ahead and press play and see if your answer matches mine. If it doesn't, then maybe go back and watch my detailed work on it. But I think honestly this is a lesson that you probably would be able to do without me, but just in case I'm still making the video. So they give the definition of a polynomial. It's really just a combination of variables and numbers put together with exponents. So they say when you're dealing with polynomials, make sure you're following order of operations. You oftentimes need the distributive property. And when you're subtracting, don't forget to subtract every term in an expression. That idea will come into play for number 2. And then I added a little reminder. When you are adding and subtracting here, do not add the exponents. So because there's a big plus sign in the middle, you have to pay attention to what operation they're asking you to do. So because it's addition, we're just combining like terms here. So we're just going to add these together, but do not add the exponents. So we end up with 5x squared. If we add the x pieces, they actually cancel each other out because positive 3x minus 3x goes away. And then we have 5 minus 10, which is negative 5. Okay, now when you are subtracting, this is where my highlighted piece comes into play here. When you're subtracting, this subtraction symbol has to be distributed into every single term of the second polynomial. So the first polynomial doesn't change, but the second polynomial, everything changes signs. So the x squared becomes negative, the 2x becomes positive, and the 7 becomes negative. Now it's just like a problem like number 1, and we can combine like terms. So 5x squared minus 1x squared gets me 4x squared. Again, don't add the exponents. And then 3x and 2x make 5x, and 2 minus 7 gets me a negative 5. Okay. All right, moving forward. Number 3, very similar, but this time we have constants in front of the parentheses that first need to be distributed. So if I distribute my 3 and then distribute my 2, I have to write my new line of work. So I have 3x squared plus 9x plus 15, and then plus 2x squared minus 6x minus 20. And now I combine like terms just like I did for number 1. So I have 5x squared, 9x minus 6x is plus 3x, and then 15 minus 20 is negative 5. Okay, very similar to this one. Again, I hope you guys are pausing the video, trying it on your own, and then double checking your answer. The only difference here is that this is a negative, so when we distribute, we just have to be careful with our signs. Okay, combine like terms. 6 minus 12 gets me a negative 6. Just be careful with your signs. You know, don't try to not ignore those. You got to think of those as negative numbers if needed. Okay, moving forward. Moving on to number 5, it says multiplication is a little more challenging, okay? So now we're switching gears a little bit and we're being asked to multiply instead of adding and subtracting. So perform each multiplication. I put a little reminder here. When you are multiplying polynomials, you do have to add the exponents here. So we have a binomial times a binomial. When we do y times y, we do have to add the exponents and say y squared. Then we do y times 7. Then we do negative 5 times y. And then negative 5 times 7 is negative 35. Now, when you multiply polynomials, oftentimes you'll have to combine like terms. Okay, and that's our final answer. Some of you might be more comfortable with the box method. Don't be shy to draw your own box off to the side. If you prefer that, you can put the y minus 5 on top and the y plus 7 on the left, or switch them, it doesn't matter. And then you can do the box method too. Anytime you do the box method, oftentimes you'll have to combine the diagonals together, just like I combined those two, and you end up with the same answer. So feel free to use the box if you prefer. When we are multiplying these, we're going to use the same method. So 2x times 3x. Don't forget to add the exponents, so we have x squared. 2x times negative 8. 6 times 3x. And 6 times negative 8. Okay, then we can combine like terms. Okay, and there's the answer to 5b. Okay, we will need that answer in the future, so keep that answer handy. All right, so then number 6 says use the distributive property to multiply. Kind of the same idea, just remember to add the exponents. Okay, I didn't like the follow-up question here for number 6, so I crossed it out. Okay, moving forward, let's look at number 7. In just a minute, we will need our calculator, so if you don't have yours, pause the video and go grab it, okay? It says now about checking our answers. You know, these problems are not like, oh, x equals 5, plug it back in to see if it works. You can't do that with these. So number 7 introduces a way for where you can check your answers, and it requires the calculator. When simplifying, you get another expression, but that other expression provides the exact same output as the original, no matter what input you choose. So if two expressions satisfy that condition, what should the relationship between their graphs be? Think about what the graph of an equation really is. So let me explain a little bit what they're trying to say here. If I were to graph the original problem here for number 5b, if I were to graph that, and then I were to graph the answer that I got after simplifying it, because I didn't mathematically change the value, I only changed the way that it looks, the expression, the way that it looks, the output, the graph, should look exactly the same, okay? So that's what we're going to be doing. That's what we're going to be checking. So let me actually write down what I just said for number 7. So if the expressions are equal, as long as you didn't make a mistake in your algebra, this should work out. So if the expressions are equal, then all their outputs are equal. A graph displays outputs, so therefore the graphs would be identical as well. Okay, now if that is confusing to you and you still don't understand what I'm saying, you'll definitely understand once we get to number 8. So let's move on. Number 8, use a calculator or computer program to graph both the original problem and your answer to question 5b. Okay, so I'm going to pull my 5b problem back out, okay, and here's where the calculator comes in handy. We're going to go to the y equals. Let me clear out what's in there. I'm actually going to go to zoom and go to number 6, zoom 6, to make sure I'm on the normal screen, just because I've been doing a lot of window changing with previous lessons. So in the y equals, I'm going to enter, using parentheses, the original problem that was given to me. Oops, 3x minus 8. Okay, so that's what I entered in my y1, the original problem. And then I'm going to enter in the y2 section my answer after simplifying. Okay, so that's what I have for the y2. Now, Because I didn't change the value of the math at all, when I press graph, they should be identical. There's the first one in blue. And then notice the red graph goes right on top of it. So you can see that they're identical. If you have an older calculator and you don't have a color screen, it is a little bit harder to see it and be able to check it. But as long as you only see one graph there, that means that you must have done it right. You simplified the expression correctly because there's only one graph, okay? So for number 9, that's all that they wanted us, or sorry, for number 8, that's all they wanted us to do. It says, do you think your answer is correct? I'm gonna write, I can only see one graph because the two are the same. They're right on top of each other. So my answer to 5B is correct. So there is a way to check your answers with these types of problems, and it's using the graphing calculator to graph your answer. Okay. All right, so there's just a couple more algebraic simplifying type of problems that we're gonna do. We can check a couple of them on the calculator as we go. Number 9, there's 3 parts to it. I kind of hate that there's 3 parts to it because you guys have done these problems for a couple of years now. They want us to multiply a binomial times a trinomial, and they break it down. They first have us distribute the x, and that's part A, and then they move to part B and they have us distribute the -5, okay, and that's part B, and then part C is combining all the like terms. I suppose we can split it up into 3 parts, but to me, it's just one problem. So if I distribute the x, I end up with x cubed, because again, I'm adding the exponents, plus 3x squared plus 4x, okay? I'm gonna bring down and write that in part C, because I'm gonna have to combine that with my answer from part B, okay? Now for part B, I'm distributing the -5 into each term, okay? So that ends up getting me -5x squared minus 15x minus 20. Now when I take this portion of the answer and write it down here, I'm gonna line up the like terms. So the x cubed is the only x cubed here. The -5x squared, I'm gonna write it underneath the x squared part from part A. The -15x, I'm gonna write it underneath the 4x. And then the -20 is the only constant. And now I add like terms. So there's only one x cubed. 3 minus 5 is -2. 4 minus 15 is -11. And then I have minus 20. Okay? So hopefully that made sense. It's really just one big problem, not 3 separate problems. Don't forget that you do have the option of using the box method if you prefer the box method. It's a slightly bigger box than the one that I drew for one of the previous problems because we have a binomial times a trinomial, so you need a 2 by 3 box. So feel free to use that method if you prefer it, okay? All right, now the last question, number 10, says use a graph to decide if your answer to question 9C is right. So I'm gonna put 9 back up there. I'm gonna enter, go back to my y equals, clear out what's in there. Enter the original problem, x minus 5 times x squared plus 3x plus 4. That's in my y1. And then my answer that I got, I'm gonna put that in the y2. X to the third minus 2x squared minus 11x minus 20. Okay, so make sure you have these correctly entered before you press graph. Okay, press graph, and it's a cubic graph, so we should see sort of an S curve. Oh, I'm gonna have to zoom out. So I'm gonna press zoom, once it's done. I just saw the red go on top of the blue, so that's good. I'm gonna zoom out so we can see the actual curve. Hopefully that's far enough. There we go. So that's the blue graph, and then you can see the red goes right on top of it. There we go. So that confirms that we did do our answer right. So number 10, I'm not gonna write anything down. That's just done on the calculator. Use the graph to decide if we are right. Both curves are on top of each other, so it is correct. All right, and that is 4-8. So I'm hoping that you guys found today's lesson easy. It's very algebra based, just making sure you know how to add, subtract, and multiply. If you have any questions, put them in the Google comment section, or you can email me and I'll be sure to get back to you quickly. Thanks for watching, and I'll see you guys next time.